Today's lesson, we're going to continue on to take a look at hyperbolas in 7.3. So today's focus is primarily looking at those asymptote equations, so finding the asymptotes of the hyperbolas, the actual equations of them, be able to write a hyperbola given some given information, and then talking about eccentricity today. So first and foremost, yesterday we took a look at the equations of those hyperbolas, so just re-emphasizing from yesterday that if it's orientated horizontally, which remember if it's horizontal parabola, that means your parabola opens up to the left and to the right like this. So if that's the case, remember in the equation form, you'll normally see the x positive first, right, over some a value, and then your y value will be the negative term over some b value. But one thing you want to note is when you're doing this, the equations are very similar. The only difference is that the slope is different, right? That it's plus or minus b over a versus plus or minus a over b. So one trick is that the number underneath the y is always going to be on top. So that number is always going to be on top. So whether it's the a versus b, whatever is the number below the y value, right, that square root of that number, that's going to be your numerator of that slope there. If we take a look at this first question, it says, find the asymptotes for the following hyperbola. So you might have some questions like this in the homework. Same with your Canvas quiz that's out there. So the asymptotes, so notice in this case, this is going to be vertical orientation. So in the back of my mind, I know it's y equals some k plus or minus the b value over a times x minus h, which in this case, your k and h value are going to be the numbers in the parentheses. So it's going to be y plus 3 since it's negative 3 inside. And remember, the number underneath the y value is going to be the number on top. So here, since the square root of 4 ends up being 2, and then the square root of 25 ends up being 5, the number to below y is always on top, so it's going to be plus or minus 2 over 5, and then it'd be x minus 4 in parentheses, because then it's at a negative 4, right? It's going to be plus 4, sorry. So then this would be the equations of your hyperbola. So one would be positive 2/5 x plus 4, and then you have the y plus 3 equals, and then the other one would obviously be the negative 2/5 x plus 4 there. All right, so let's take a look at another one here. So here we have another equation, y plus 4 squared over 4 minus x minus 2 squared over 9 equals 1. So the goal is to find the equations of the asymptotes. So again, the trick is notice whatever's underneath the y value, right? The square root of that number. So here it ends up being, the square root of 4 ends up being 2, and then the square root of 9 there ends up being 3. Whatever the y value is, that square root, that's going to be the one on top. And so the formula ends up being y minus my k value, which ends up being a negative 4. So it's going to be minus a negative 4, which ends up being plus 4 in the mix there, equals. So since my, looks like this case, my y value underneath is 2, it's going to be plus or minus 2 over 3, right? The y values are always on top, and then it'd be x minus 2 in parentheses. So this would be the equations of that hyperbola. If you had some questions on Canvas that asked you the equations and it's solved for y, then the expectation would be, yes, you'd have to solve this for y by distributing the positive 2/3 through, so it'd be 2/3 x minus, if you distribute it to that second term, right, you're taking a number times a fraction, that ends up being 4/3. You just take that number times the numerator there. And then if I'm going to subtract 4 to both sides, when you want to think of subtracting 4, you're going to want to think of common denominator work there. So instead of subtracting 4, we want to think of it subtracting like 12/3, because that'd be the same denominator there. So on the left side, we're just left with y equals 2/3 x, and then if I subtract 12/3 from 4/3, that becomes a negative 16/3 overall. So that would be one equation if you were to solve for y, and then you'd have to do the same thing, but now you're distributing a negative 2/3. So it's going to become plus on the other side, but you'd still be subtracting 12/3 of it. So the other equation would end up being y equals negative 2/3 x. And then since you have a positive 4/3 minus 12/3, that's going to be a minus 8/3 overall. So then those would be your two equations if you had to solve for y, but we do accept that plus or minus form in the beginning. All right, so the last couple things is just taking a look at if we're given some information, can you write the equation of the hyperbola? And so this is similar to if we had like the parabolas and the ellipses, where the first step is let's graph this scenario to figure out how it's going to be orientated. That was terrible y-axis. There we go. And so if I graph the foci points here, which is at 1, -5, so here's one focus point, and then the other one's at 1, 1. And so if your focus points is orientated vertically like this, then I know in the back of my mind my hyperbola is going to be orientated vertically. So it's going to look something like this. And remember, if it looks like that, then the form of that is going to be y minus k squared, and then the x term is going to be the -1 over a squared over b squared, right? So that would be our formula there, where the a value would then be the distance between the two vertices. So halfway between the focus points there is going to be the center of it. So if I take a look at my distance here, which ends up being full 6, then 3 units down, 3 units up, right there at that coordinate of 1, -2 would technically be my center. So I know that my k value is going to be -2, so it'll be y plus 2 squared over some a squared, and then we know it's going to be x minus 1 squared over some b squared. And then now that we know where my center is, to figure out my a and b value, it's really just a matter of looking at the distance of that focus point. So if you notice, the focus points there is a distance of 3. That's the c value. And remember, your c value comes from the sum of those two values squared. Since I know what the c value is, which is 3, right? 3 is going to be my c value here. And I'm telling you that the transverse axis is the length of 4. Remember, that comes from twice whatever a is. So there's some hidden value that a is going to be 2 in that case. So since a is 2, then your vertex is going to be right there, and your other vertex is going to be down 2 from that point. So if my a value is 2, and I try to use that equation to solve for b, 3 squared ends up being 9. I get 4. Looks like if I subtract 4 over, I get 5. So my b value ends up being the square root of 5. But in the equation, it's going to be 5 itself. So if I put everything together now, I know what my center is. My a value is 2, so it's going to be 4 on the bottom. And if your b value is square root of 5, when I square that, that just ends up being 5 on the bottom. And so this ends up being the standard form of that hyperbola, given that situation. So strategies-wise is first kind of plot what's given, and then you also might be given some information about either the transverse axes, the conjugate axes, whatever that might be. But if you plot how the points are given there, the focus, whether it's the vertices, focus, your center point itself, you can kind of work backwards to figure out your a and b values to be able to put it into that equation. So let's take a look at one more here. Here I give you the vertices, and then I also give you the conjugate axes. So remember, the conjugate axes, that's twice b. So that number 6 there that you see, that's going to be twice the letter b. So that means b's got to be 3. So let's keep that in the back of our mind. But now if I sketch the vertice points, which is at -3, 10, which is way up here, that's one vertice point. We'll label it v. And then -3, -2. That's another vertice point. So just noting that the vertices are orientated vertically again, I know my hyperbola is going to look something like this, where it's orientated vertically. And since it's orientated vertically, it's going to have this form, y minus k squared over a squared, and then it'd be x minus h squared over b squared equals 1. We can figure out what our center is just by dividing basically the distance of your vertices there, which looks like to be a distance of 12. If I divide that by 2, then that tells me my center is going to be up 6 and down 6 from those vertices, right? So that's where my center is going to be, which as a point, if I add 6 to the y-coordinate there of that second one, that ends up being at -3, 4. And that's the same point as if I were to subtract 6 from the y-coordinate there of that first one. So there's my center, so I know it's at -3, 4, so that'd be y minus 4 squared minus x plus 3 in parentheses squared. You know it's supposed to equal 1. We have a hidden b value of 3, so under the bottom of that second term, it's going to be 3 squared, which is 9 on the bottom. And remember, your a distance is the distance from your vertice to the center. So it looks like the a distance there is going to have a distance of, looks like 6. Right? And so since my a distance is 6, then if I square that on the bottom, that's going to be over 36 itself. So here is my standard form of the hyperbola. So the last thing we got to talk about is what's called eccentricity for hyperbolas. We still find eccentricity by taking c divided by a, but now with any of these ones dealing with hyperbolas, you should get a value that's bigger than 1. Remember, we got values that was between 0 and 1 if it was really a circle or a hyperbola, or sorry, parabola or an ellipse. You got values, and if it was equal to 1 exactly, that's when parabolas would end up popping up here. So these are ones where the eccentricity is bigger than 1 for these ones. So if you take a look at this one, just a quick example of finding the eccentricity here. So remember, the formula for eccentricity is taking c divided by a. Remember, your a value is always underneath that first part, so it's the square root of that first number. So a value is going to equal the square root of 32, so we can plug that in for a, square root of 32. And then remember, our c value is found by taking the square root of the sum of those two numbers underneath. So because c squared is going to equal 32 plus 25, and so c squared ends up being, looks like 57, so c is going to be the square root of 57 on your calculator. So if you take the square root of 57 divided by the square root of 32, which you should get a number bigger than 1 here, square root of 57, press enter, and then if I divide that by the square root of 32, sorry, and press enter, you should get an answer of 1.335 if I did 3 decimal places here. So that would be the eccentricity value for this hyperbola. So that concludes today's lesson. So you can check out the additional homework problems out of Bookwork 7.3. And as always, reach out to me if you have any questions or concern, but have a great rest of your day.